Okay, so hey, what's up? I had learning objective 6.6, and we're going to be using the direct method to find the standard enthalpy of formation. So, in the problem, we're given the chemical equation, which is the dissolving of HCl gas in water, and it yields H plus ions and Cl minus ions. And it gives us the standard enthalpy of the reaction as negative 74.9 kilojoules per mole. Also, we are given that the standard enthalpy of formation for the H plus ions is 0. So part A wants us to calculate the delta H of formation for the Cl ions. So we can use the equation for the delta H of formation for a reaction. So that is products, sum of the products, delta H's for the products, minus the sum of the delta H's for the reactants. So we're given the delta H for the reaction, so we already know that one. So we're going to have to use algebra to find the delta H formation for the Cl minus ions. So we put in negative 74.9 for the delta H of formation. And for the products, we want the sum of the delta H of formations for the products. So it is given that H plus formation is 0, and we want to find the delta H of the Cl ions. So we're going to just put that as X. We're going to subtract the reactants. We only have one reactant, and that's HCl gas. So we're going to look at the standard enthalpy chart, and we find that the standard enthalpy of formation of HCl gas is equal to negative 92.3 kilojoules per mole. So we're going to put that in for the reactants. So now we just have to solve for X, because that's the Cl minus ion delta H of formation. If this were to have a coefficient, we would have multiplied the coefficient by the standard enthalpy of formation, but it does not, so we good. Okay, so just use your algebra skills, and then you can find the standard enthalpy of formation. So we subtract 92.3 from each side, and then we get X as equaling negative 167.2 kilojoules per mole. So that is the standard enthalpy of formation for Cl minus aqueous. Part B, it's not really related to Part A, but they give us the standard enthalpy of formation for OH ions, which is negative 229.6 kilojoules per mole. And they want us to calculate the enthalpy of neutralization when 1 mole of a strong monoprotic acid, like HCl, is titrated by 1 mole of a strong base, like KOH. So we can start off by just writing a chemical equation. HCl aqueous plus KOH yields H2O liquid and KCl aqueous. It's already balanced, so we can just write the net ionic equation for the actual reaction going on. So that's going to be H plus aqueous plus OH minus aqueous yields H2O liquid. So this is the equation we're going to use. Okay, so we're using the direct method to calculate the enthalpy of neutralization. So we're going to use the products minus reactants formula. So delta H of the reaction, or neutralization, is equal to the products. So we have to look into our chart and find the delta H of formation for H2O liquid, which turns out to be negative 285.8. And then we subtract that of the products. So we were given in part A that H plus ions is 0, so we do 0 plus OH, we're given that to negative 229.6. And then it's just adding together those numbers. So negative 285.8 plus 229.6, and we get negative 56.2 kilojoules per mole for the delta H of neutralization for this reaction using the direct method.